Look down at whatever metal is near you right now. A doorknob, a fork, the frame of your phone. Somewhere in the deep past, that metal was a dull, ugly rock sitting in the dirt, and somebody had to figure out how to turn it into that. Not gold, which practically announces itself by glittering in a riverbed. Not copper, which sometimes shows up as shiny reddish chunks you could just pick up and hammer into shape. Iron doesn't do that. Iron hides. And the story of how humans cracked that hiding place is stranger, older, and weirder than almost anyone realizes. You probably think it went something like this. Someone tossed a rock into a fire, it melted, and boom, ironade. That is not even close to what happened. The real story involves outer space, several thousand years of failure, and the discovery that may have happened almost by mistake. In a furnace nobody was even trying to make iron in. Before we get to any of that, you need one basic idea in your head, and it's simpler than it sounds. Almost every rock on Earth that looks reddish or rusty brown is carrying iron inside it, just not as metal. Think of it like fruit that's already gone bad. The iron and the oxygen in the air found each other a long time ago and basically fused into a chemical marriage that doesn't want to break up. That marriage is what we call rust, or in ore form, iron oxide. So when your ancient ancestor looked at an iron-rich rock, they weren't looking at hidden metal the way you'd look at a wrapped present. They were looking at something that chemically had already given up its metal identity millennia earlier. To get the iron back out, you don't just need heat. You need to force that oxygen to let go. And forcing a stubborn chemical bond to break apart with nothing but fire, rock, and air is a genuinely absurd problem to solve with Stone Age tools. Keep that in mind, because everything that follows is really the story of people accidentally discovering a trick without knowing they discovered a trick at all. Let's start with the fact that sounds the most like science fiction, because it happens to be true. The very first iron humans ever used didn't come from the ground. It came from the sky. Meteorites made of metallic iron occasionally survive their fall through the atmosphere and land intact. And unlike ordinary ore, that iron is already pure, already metal, ready to be hammered. Archaeologists working in Egypt uncovered small beads from a burial dated to around 3200 BCE, and when researchers ran chemical tests on them, they found nickel levels that only occur in space rock, not in anything mined from the ground. People were wearing meteorites as jewelry before they had any idea how to smelt iron from ore at all. And here's the detail that should make you sit with this for a second. In several ancient languages, including Egyptian and a few from Mesopotamia, the earliest words used for iron translate roughly to metal from the sky. They weren't speaking poetically, they were being painfully literal. As far as they knew, this stuff genuinely fell from heaven, because that's the only way they'd ever encountered it. Kind of makes you wonder what future archaeologists will assume about us based on our leftover space junk, honestly. Now, here's where the misconception really needs to breaking. A lot of people assume that once bronze was figured out, iron was just the next logical step, an upgrade someone deliberately chased. It wasn't. Bronze was actually the better metal for a long time, and that surprises almost everyone the first time they hear it. Bronze, made from copper and tin, could be melted at temperatures Bronze Age furnaces could reach, and it produced strong, reliable tools and weapons. Iron ore, sitting in those same furnaces, simply refused to cooperate. It needed heat far beyond what those setups could generate to properly liquefy, so smelters who tried using it the same way they use copper just got a lump of stubborn red rock and a wasted afternoon. For a long stretch of history, iron ore was basically considered a disappointing, useless material. Nobody was chasing it as the next big thing. If anything, it was the metal that kept failing the test. So how did the failure eventually flip into the biggest material revolution in human history? This is where it gets genuinely wild, because the breakthrough wasn't really invented the way we usually imagine inventions happening, with someone having a light bulb moment. It was closer to an accident that kept quietly repeating itself until somebody paid attention. Metal workers trying to get hotter and more efficient copper furnaces had already stumbled onto a few upgrades, burning charcoal instead of raw wood because charcoal burns hotter and cleaner, and building taller enclosed furnace shafts because a tall enclosed chimney pulls in more air and drives the fire hotter still. None of that was aimed at iron. They just wanted better copper and better pottery. But somewhere along the way, iron-rich rock ended up inside one of these increasingly hot, increasingly oxygen-starved furnaces, maybe mixed in on purpose to help separate impurity, maybe just sitting in the furnace lining itself. And something happened that nobody had planned for. Here's the part that deserves a slower breath because it's the single strangest twist in the whole story, and I promised I'd circle back to it. The iron didn't melt. It never needed to. Inside a hot, low-oxygen furnace, burning charcoal produces a gas that is chemically hungry for oxygen, and that gas goes looking for oxygen wherever it can find it, including inside the iron ore itself. It essentially strips the oxygen away from the iron atoms while everything is still fully solid. No liquid metal pooling at the bottom like with copper, no dramatic molten pour, just a strange, spongy, dark lump quietly forming inside the coals, made of real metallic iron fused together with leftover slag. When someone eventually broke open that furnace expecting the usual copper, they found something that had never existed in human hands before. Something that dented instead of shattering when you hit it. Something that could be reshaped again and again with nothing but a hammer and more fire. This is the moment worth saying. Plainly, without hedging it in any way, humans discovered how to make iron before they ever understood why it worked, and they didn't need to melt it at all. That single sentence undoes basically everything people assume about how metals get discovered. There was no eureka lab moment. There was a furnace doing something nobody had designed it to do, and a person clever enough to notice the result was actually useful. What follows that discovery is centuries of something even more impressive than the original accident. People learning to read a process they had zero theoretical understanding of purely by watching it closely enough, over and over, generation after generation. Early iron workers learned to judge furnace temperature by the exact color of the flame licking out the top. They learned which ores, by weight and color alone, reliably produced a better lump of metal. They developed a habit of leaving certain pieces sitting in the hot coals of the forge for hours, and noticed, without any idea why, that those pieces came out harder, sharper, tougher. What they were accidentally doing, we now know, was letting carbon atoms slowly work their way into the iron structure, quietly turning soft iron into something closer to steel. They had no concept of atoms. They had no concept of carbon as an element. They just had thousands of repeated observations passed from a master to an apprentice, refined slightly each generation until an entire body of extremely precise, entirely unwritten knowledge existed in the hands and eyes of people who could not have explained a single part of the chemistry behind it. Why didn't this spread instantly once it worked? Mostly because early iron, fresh out of that furnace, actually wasn't better than good bronze. It was softer, it bent. For a long stretch, bronze remained the smarter choice for anyone who could still get it. Iron's real advantage wasn't quality at first, it was availability. Tin, the ingredient bronze absolutely depends on, only exists in a handful of locations on the planet, so making bronze required long, fragile trade routes stretching across seas and mountain ranges. Iron ore, on the other hand, sits almost everywhere, in ordinary dirt, under practically every ancient village on Earth. So when those long-distance trade networks collapsed during a chaotic stretch around 1200 BCE, and several major civilizations fell apart within roughly the same 50 years, the tin simply stopped arriving. Bronze became scarce and expensive almost overnight. Iron, unglamorous, humble, locally sourced iron, was suddenly the only option left standing. Necessity, not superiority, is what actually kickstarted the Iron Age. Zoom out from the furnace and the forge for a second, and you start seeing something bigger than metallurgy. Every major leap in material technology throughout human history follows roughly the same quiet, unglamorous pattern. It's rarely a genius having a single grand insight. It's usually ordinary people solving a completely different, smaller problem who happen to notice an unexpected result and are curious enough to not just shrug it off. Iron becoming common also quietly reshaped who got to hold power. Bronze had been expensive enough that only kings, temples, and elite soldiers could really afford serious tools and weapons made from it. Iron, being cheap and locally available, ended up in the hands of ordinary farmers and ordinary soldiers. A plow tip that once belonged only to the wealthy became something a regular family could own. That's the quietly uncomfortable part of this story worth sitting with for a moment. The same material breakthrough that let common people grow more food and build sturdier tools also armed far larger populations for far larger wars than the ancient world had ever seen before. A better plow and a better sword came from exactly the same furnace and exactly the same discovery. Progress, it turns out, rarely arrives with a clean conscience attached. So think again about that piece of metal near you right now. It traces back through an unbroken chain of trial, error, and stubborn curiosity to someone standing over a furnace that wasn't supposed to be making iron at all, staring at a strange dark lump that shouldn't have existed, and deciding to hit it with a hammer instead of throwing it away. They had no chemistry, no idea what an atom was, just fire, rock, patience, and the willingness to pay attention when something didn't behave the way it was supposed to. That's really the whole story, and maybe the whole point. So here's a question worth sitting with before you close this. How many accidents happening around you right now, this week, are quietly waiting for someone patient enough to notice them?